Hi, everyone. I'm Sarah Larson from the Multiplicity Lab Group at Northwestern University. Today, we're going to explore one type of look, think, talk activity where the question you ask of students is, how many? As a quick reminder, in look, think, talk activities, you first show students an intriguing mathematical image and give them time to look. This can be done on a shared screen, or you can print copies for students. Then you pose a central mathematical question and give students time to think. If students have printed copies, you can invite them to annotate as they think. Students can also use manipulatives as an entry point into the task. Finally, ask students to talk about the question with one another and as a whole group. The goal of these discussions is to elicit and encourage multiple ideas, strategies, ways of seeing and thinking, and connections, all while making room for multiple voices. The question how many is fundamentally about counting. But of course, there are many big ideas involved in this seemingly simple act. Counting involves connecting quantity and number. That is, connecting what 8 objects in the real world looks like to the number word and symbol for 8. How many often involves composing and decomposing number. Students often subitize smaller quantities like 4 and 4 and then compose them into the idea of 8. This can sometimes involve making 5s or 10s to make counting easier. How many involves the question, how many what? Students have to figure out what units they are counting. If students notice a structure to the units, they can use that to support counting, sometimes using equal groups and connecting area and multiplicative thinking. You can see that asking students how many can be an entry point into many big ideas. These are just a starting point. Let's look at a couple of examples. How many do you see? The first question you and students might grapple with is, how many what? There are many items in this image that could be counted and many ways to count each one. This is a great image to support subitizing and composing number with younger students. Subitizing means recognizing small quantities like 2, 3, and 4. This can help students compose larger numbers out of those smaller quantities. Students might see 4 kiwi slices right away because they're arranged like a dice. Or they might have seen them as 2 and 2, which together make 4. But with the watermelon, students might see 4 pieces and 2 more, which together make 6 pieces of watermelon. Of course, students might have seen these 6 in many different ways. In images like this, it's critical to ask not just how many do you see, but also how do you see them? This question welcomes a multiplicity of ways to see and helps build flexible thinking about number. Let's look at what happens when we change the image. With this array, we've asked a more specific question, how many squares are shaded? To answer this question, students will need to develop strategies for decomposing the image into segments they can count and then recomposing the total number of shaded squares. This might involve using multiplicative thinking with the row and column structure of the array. Students might, for example, decompose the shaded region into rectangles, find their area, and then add them together. This is just one way to use that strategy. Taking a completely different approach, students could find the area of the entire array. Here it's 35 squares, and then take away the 10 unshaded squares. You can see how these two approaches together, like the previous additive one and this one, seamlessly connect addition and subtraction as 2 ways of solving the same problem, while also drawing on multiplicative thinking. There's just so much going on in how many tasks with arrays. When we ask how many with dice, students might choose to count the dice themselves or the dots on them. If they choose to count the dots, there are several structures they can draw on to help them, including the ways the dots are arranged on dice, the rows and columns in the image, and the patterns in the rows. This image offers the opportunity for students to make 5 or 10 as part of composing, either by combining the 2s and 3s to make 5s, or each row makes 10. If students use this structure, they can count the dots by skip counting the rows. This is just one way and one set of big ideas that students might engage with in this image alone. We have dozens of how many activities in Multiplicity Lab. To find these, begin looking at the Look, Think, Talk tab. You can use our filter to select the question how many. And if you'd like to narrow your search, you can select a grade level or material, like dice, dominoes, or arrays, to match your goals. Try a how many activity with your students tomorrow.